Hi everyone, this is Live Doppler 13 Meteorologist Sean Ash. We appreciate you logging on for the latest edition of 13 Weather Academy. One of my favorite subjects. I love winter weather. Sometimes I pull my hair out trying to put together a winter precipitation forecast, and we're going to talk about some of the complexities and the different types of winter precipitation we can have. Thankfully, on this radar presentation that I'm showing you now, we have all of the types here, and it is quite a mess across the central and southern U.S. So this is what the radar would look like in this situation. The green is rain, the blue areas are snow, and then when you get into the pink, that can be a combination of snow, sleet, and something called freezing rain. And we know we have to have cold air for winter precipitation. But I will tell you that sometimes you can actually be above freezing at the surface and have sleet and snow, okay? So a lot of it depends on not only what's going on at the surface, but also what's going on just above and middle layers of the atmosphere here. So in this particular situation, east of Oklahoma City into Arkansas, the atmosphere producing rain. Okay, then you get a little farther to the west into the Oklahoma and Texas panhandles. It's cold, not only from the surface, but aloft, and a lot of that is falling as snow. Then we get into what we call the mixing bowl here. In this particular setup, we are getting some pretty significant freezing rain across the central portion of Oklahoma down through central Texas. Okay, we show you the temperatures at the surface. So Dallas in the upper 30s to near 40 degrees. Oklahoma City, you're like, oh, it's only 31. Well, it's 31 at the surface, but above that, it's above freezing. And that precipitation that's falling is falling as liquid, but when it's hitting those sub-freezing surfaces, trees, power lines, sidewalks, it freezes on contact. This is what it looks like in an atmospheric profile. Most precipitation starts out as frozen. If the warm layer that I'm showing you is deep enough in the atmosphere, that will melt. And if it's above freezing from that mid layer all the way down, it falls as rain. No big deal. I mentioned the freezing rain. So it starts as snow, it melts, and it is liquid when it hits the surface. But that, again, the sidewalk is below freezing, the trees, the power lines below freezing, so it coats up as ice. And sometimes, again, starts as snow, so it starts as frozen, it melts, but then it freezes before it hits the ground, and it forms a little ice ball, and that's what we call sleet. And then there are times, and this makes our job a lot more easier, when it's frozen from start to finish, and that's snow. Those are the easier situations for us. But oftentimes here in central Indiana, we may have all four types, and then we're trying to find exactly where that line is going to be. It can prove to be very difficult. And sometimes it's a degree or two change at the surface, and just aloft can change the entire forecast from all snow to, oh, we've got some sleet now, or we've got freezing rain. This is what freezing rain looks like when it freezes on contact. So again, it's liquid, but it's hitting this tree branch that's below freezing, and it creates this layer of ice. Well, if you hold ice cubes in your hand and you have you put water in your hand, you know that ice is heavier. So that's what creates the weight on the trees and power lines. And in some instances, if you're in an ice storm, the ice accretion can be 1 inch to 2 inches in diameter. And if you get to 2 inches, that is easily enough to start snapping trees and power lines and sometimes even power poles. We don't like to see that. So when we put a forecast together, we use something called a snow ratio. So how much liquid are we expecting from the system? And then we convert that, what we call a snow ratio. So if we have 1/10 of an inch of liquid in a 10-to-1, which is typical snow ratio for us, that would produce 1 inch of snow. If there's 1/2 inch of liquid, that would typically produce 5 inches of snow. And then if you have 1 inch of liquid, which is a pretty juicy system, that produces 10 inches. Now there are times when the atmosphere is colder, and that produces what we call higher ratios. So sometimes we may get into a 20-to-1. So that 1/10 of an inch of liquid fluffs up to 2 inches of snow. 1/2 inch, because we're multiplying it twice here, would produce 10 inches. And then 1 inch of liquid in a 20-to-1 ratio produces 20 inches of snow. Now, sometimes the ratios can be even higher. And so that's part of our forecast process as well. So there's a lot going on, not only trying to find the rain snow mix line, but also trying to use the right ratio. And here's another way to look at it. So this is a tank of liquid that has a 1/2 inch of liquid, and this is what it would look like from a snow perspective. So 5 inches of snow, again, if we're using 10-to-1. So how much snow do we typically see in an average winter in central Indiana? 26 inches. I've plotted the last 9 winter seasons for us here, okay? So you have to go all the way back to 2013, 2014 to get an above average winter, and that was a big one. That was almost 56 inches. That's a historical winter for us. But you can see the last several have been fairly wimpy for the most part. And we'll see what this particular winter brings for us. These are some of the highest totals we've had. I mentioned 2013, 2014, third snowiest on record for central Indiana. 81, 82, over 58 inches of snow. That's our snowiest on record. Average first date of snow is November 19th. However, 1989 in the middle of October, in fact, it was October 18th, 19th, and 20th, we had a snowstorm that produced over 9 inches of snow in some locations. Now, back in 1923, we had to wait all the way until early May to get the first snowfall. That was the latest first snow on record. 10-inch snowstorms in central Indiana, specifically Indianapolis, are not as common as you might think. The maximum snow we've had in a 24-hour time frame was just over 12 inches, and the maximum for one storm is 16 inches. So that puts everything into perspective. We will see how this winter will play out for us. We are going into what we call a La Nina phase. So that can bring a wide range of outcomes for us. Sometimes it can produce some big winter snows, and sometimes not so much. So we will see. Hopefully you've learned a bit about the complexity of putting a forecast together and what just small changes in temperature can change the outcome of a particular winter situation. So thanks for checking us out here on 13 Weather Academy. Have a great day.